Alright, so in the last session we covered till manual learning, the traffic learning, module 6, and today we have to start with the module 7, which is parameters, learning parameters. So before we go that, I would just like to quickly run through the lab and try to show you what options we have there for the parameters and some of the stuff that we discussed in the last session. Okay, seems our F5 is booting up, one of them, and let me try to log into the other one, which would have, I think, booted up. So now we can go ahead.
No one? No one? Did you share the screen? Because we are not able to see any screen.
Sorry? You can't see my screen?
Yeah, no.
Oh, okay, I think my bad. I missed to share, just give me a moment. I think now you should be able to see, right? Okay, let it come up. Alright, so working with parameter learning. When configuring parameters at any level, ASM has the capability to learn those parameters and implement those based on the security logic. The learning tool determines how to configure the parameter in the web application. Learning also provides parameter suggestions. This applies only when file type and URL parameters are already defined within the security policy. So parameter logic, understanding the parameter logic. With the addition of parameter levels comes the associated policy logic of how to implement those parameters in the security policy. The policy enforcer uses prioritization in parameter logic. The logic is top to down and from more specific to least specific, which is URLs and global parameters. So if a parameter is defined more than once in a request context, only the first match will apply. So if the first match for that parameter says allow, no matter how many times this same parameter is there in the request, still it will be allowed. But if the first match of that type of parameter, let's say it's a greater sign parameter, and then based on that, if it is to be dropped, then the ASM policy is not going to look further for the same parameters or different parameters ahead. So for example, if global parameter username is defined as a static parameter type and the URL login.php is defined as an user input type, no violation will be found when requesting URL login.php with username having a value which is not listed as a static parameter type under the global parameter settings. Right? So what you have done, you have defined two things in the policy. one, you have defined the global parameter username. Second, you have defined this parameter for a particular URL, login.php, because login.php is a page that requests user credentials. So if you have defined the correct URL and the parameter which is present in that URL, then you will not get any violations, because that's already defined, and that's a page where you expect the user to put the username, right? Now the value of the username can be anything. Now in that case, if there is some special character and that is not allowed, then that might at a second level cause a alert. So now to reiterate, the more specific definition will be applied. With global parameters, you can define the parameter name as a regular expression. If you select this option, this parameter will be defined as static type of parameter. So for example, the request is using the HTTP method get, and the URL is account.php, and this is your parameter. ID is equal to 123. It's using HTTP protocol and version is 1.1. This ID is the parameter, and its value in this case is 123. For example, when you log into Gmail, there's a login or the username parameter, and what username you put, that's actually the value of that parameter. So flow parameter is defined, yes. Positive check on parameter, yes. Then global parameter defined, okay, and then you get the access. If flow parameter is defined, no. URL parameter defined, no. Global parameter defined, no. Then negative check. Okay, so that's how the parameters basically behave. Let's try login and check few things about parameters. Okay, so I'll go to the security section here. Once I go here, I'll go to the application security parameters. And I think we have a policy automatics configured over here in blocking mode. So the last session, last to last session, I think we defined this username parameter over here, and it's a global parameter, and we haven't defined any static values for it. And yesterday we were talking about character sets, right? So that means basically parameter value. Parameter value is actually what all characters or values you want to allow in the parameter. For example, if in the URL you are accessing, you're putting login is equal to login.asp and username is equal to something. Now that's something, that value that you want to allow in the as a parameter value, what meta characters you want to allow. Now by default, all these meta characters that you see over here is dropped. I gave you an example in the last session that 0x20 is equal to a space from coding perspective, and it is by default disallowed. Now if the application team says was 0x20 is something that we want to allow because we have some spaces as per our code, then you have to change the setting of this parameter to allow and apply for this particular policy. You will not change it globally for all, because that will impact all the policies. So we will just change for this particular policy, and then we will apply it. Now what happens, any request that comes in and has a space in the URL, or in other words ASM logs it as 0x20, the ASM is going to not block it, because we have now allowed it, making an exception from the default behavior. The other thing is like most of the things are disallowed. So sensitive parameters. Sensitive parameters feature is used to protect sensitive user input information such as passwords and credit card numbers in a validated request. the contents of sensitive parameters are not visible in the ASM GUI or the log files, right? Because sensitive parameters, as you can see, it's a credit card or password, so that would not be visible in an encrypted in a decrypted manner in the ASM GUI or log files. And this is a good security practice that hides this information from administrators of the big IP ASM system. Let's try and access this policy, this virtual server with which this policy underscore automatics is bound, so that we can test around. So its IP is 24.24.100.100. Let me try and browse to it, see what ASM has to do for us. Oh, it's blocked. So now we're gonna check why is it actually getting blocked, and we'll see into the logs as to what's blocking this one. Let's go to the logs. Alright, so this one I think is the relevant one that shows why it's getting blocked. Okay, so let me open this log. So many things to block it, and so many violations. I mean, it's finding out. So it's finding expired timestamp violation, illegal file type violation, illegal URL length. Yesterday we did discuss about this, URL lengths and violations related to that, and illegal request length also is illegal. Now, so many violations, right? Basically, if you look at these all, the second one, illegal file type. Now, if you see illegal file type in the violation category, then obviously the others will follow most of the time. So just based on the experience, I'm telling you, it's not that 100% it will happen, but most of the time. So if I fix this, then the other two will get fixed. And a combination of all these, what has that ASM concluded from it is that these could be the attacks that might be happening: buffer overflow and forceful browsing. Means too many requests coming in, which is not relevant. So that's what ASM has found out, and the session ID, and this one has a violation rating of 3. So if you guys remember, we discussed that violation rating is from 1 to 5, and as we move from 1 to 5, it gets more severe. Basically, 1 is ignorable, it's very less critical, but 3 is kind of medium level critical, and 5 is very high critical. And this is the source IP and port from which the ASM was getting the request. So let's go ahead and solve this issue. So illegal file type. Okay, let's first click on the expired timestamp. Now what this has to say for me. Okay, so defined expiration period is 600 seconds. Time passed since expiration period ended is so many seconds. And ultimately where it impacted is the ASM cookie. So now, in order to, this is a genuine thing, so I may not make an exception for this because the session was left idle so long. That's my bad. So what I will do now is let's keep it on hold at this time and work on the other ones, and then we'll try and access again and see what happens. So illegal file type. So file type is ICO, and this file type is classified as illegal by ASM. So let me see what is my configuration for the file types for this particular policy. So in that case, I'll just go back and go to file types. Okay, see, so I've just allowed this no_ext as the file type. That's why that ICO file type is getting blocked. So what I have to do is I have to actually add that particular file type as well. And I can simply add wildcard to make my life easy, but that would again be risky. So I'll just add explicit ICO as the file type. Now Okay, and I'll leave the URL length, request length, all these things for this particular file type as default, and I'll click on create. Now let's go back and see the other violations which were saying something about the URL length and the request length, and then based on that we will come back to this screen and allow the lengths. So let's see this violation we were looking at. Okay, why it classified illegal URL length? Because detected URL length was 12 and expected was 0. See, expected was 0 because this file type was not configured in the policy. Now let's see if detected URL length 12 is allowed, and what about the request length? It's 445. And okay, so if these are within the limits that I have configured, then we are good to go. So let me go back and see that. In this section of file types, and the one I added, I'll select that one. So now we see that the file type, the requested URL length, and the request URL length is 100, so it was observed 12, so that's within these limits, and request length which was 445, and the limit that we have configured is 5000 bytes, so that's also again in this permissible limits, so we need not worry about this. So we're good to go. Now let's apply these changes to my policy and then see how it goes, because I still have some changes to be applied to the policy. Okay, I'm gonna clear the cache from the browser again and check it out. Alright, let's put in the IP. Okay, still it's getting blocked, and this time the support ID is 798. Let me see what's the issue now. So you go back to logs, and 798 I think was the request ID, right? So I'll have to figure out for that one. Yeah, this is the latest one anyways. So let's see what we're missing now. I think it's okay. So now I only have expired timestamp, the one which we did not fix last time, so that means the other three got fixed. So definition, expiration period, Time passed since expiration. This okay, fine. So we have to work out on this one. So let's see how we're gonna fix this. So for this one, we will go back to our blocking settings. Okay. So for instance, if we go back over here, policy building, learning and blocking settings. Okay. Okay, I have to choose this correct policy. This is the one I'm going to look for. Okay, in these protocol violations which we discussed in the last session, this is where you find the protocol violations and what is the status for each violation. So mine was related to the cookie, right? So for the cookies, we find it over here, and okay, so cookie not RSC compliant. See this one, expired timestamp. It's in a block state, right? So this is what actually is blocking my request. Now, if I uncheck this one, what actually I'm doing is I'm making my policy a bit more relaxed. So actually, based on the logs, I'm relaxing it because I don't know the exact behavior of the application, that what is the timer for the cookie I have to keep. So I'm going to relax this in absence of that information, and then I'm going to save this change. Okay, now let's try and clear the cache and hit back again. So you can see, like, even the minute things, and the cookie or the RFC compliance misses can cause you can block and generate false positives. So the best thing you should know is how to check the logs and where to go ahead and verify the settings of the configuration and make an exception maybe. Alright, so let me just refresh this. Alright, there you go. It's working fine now. And if I check the logs again, there would be logs, but this time it would not be in the violation category. It would be when I'm checking all requests, in that it will show it as a allowed log basically. Okay, so and if you want to see this log of when we were able to access, it wouldn't show up here because it's filtering illegal requests. So I'll filter all requests and it should come up there. Yep, see, and now you see a green check mark which indicates it's being allowed, and these are the response codes. Anyways, so we were talking about the next aspect, which is parameters, and Yeah. So okay, and let me filter the correct policy automatics. Yep. This one has this wildcard parameter, and then you have username. I'll just remove this one, and then we're gonna test out and look how it goes. Uh, okay, still it's working because I'm not using any parameter that is actually blocked. Okay, so let's move on. Okay, that was about the parameters. It's not a very big topic, and you should you should mainly know where to configure parameters, like how to allow a parameter or disallow, and how to do that specifically for a URL. Once you know that, you will be able to make exceptions for some parameters as and when required. Okay. Now the next thing in line is policy builder. So what we are seeing over here, this is for prompting us over here. The policy builder is in automatic mode for the policy underscore automatic security policy, and the system learned so and so number of file types, so and so number of URLs, so and so number of parameters, and the policy builder last updated the security policy in 19 minutes. And so this is what we're going to discuss now. So this is something which is automatic. Now it depends upon us whether we want to do the learning manually. In that case, the policy builder needs not be enabled, but in case we want to the ASM to be smart enough to continuously keep on automatic learning and give us suggestions, and make on exceptions, so then the policy builder is the thing that does it. So let's read about it. Introduction to policy builder. The policy builder is a tool used to create a security policy. The policy builder parses requests and responses and populates the security policy with the entities it discovers. These entities consist of file types, URL parameters, meta characters, and flows. Once the security policy is created, you can begin the tightening process. The security policy initially allows all requests and responses and populates all entities with wildcards. The policy builder will then add more entities and tighten the security policy. Once there is no more tightening and learning to be done, the user can move to blocking mode. So the policy builder is, if you define in one line, is a tool used to create a security policy. So when we are creating the policy, if we do create an automatic policy, then policy builder gets activated. So whenever you create the policy manually, remember initially when we created the policy, there were 4 methods: create automatic, create manually, create using a vulnerability scanner, and create using XML or SAML policy, right? So this gets introduced policy builder only in those cases when you have created the policy automatically, not manually. So when building a policy, you must decide the traffic source. The two options are live traffic and system generated traffic. When using live traffic as a traffic source, the policy builder analyzes logged requests to and responses from the web application. You can also configure a trusted IP, which denotes traffic coming from this IP address is safe traffic. When using system generated traffic as the traffic source, the policy builder emulates user behavior by browsing the web application. Then the main option that we use most of the time is policy building using live traffic. That's what is happening in our lab scenario, and that's why we keep on getting these updates as the traffic flow comes in. So when building a security policy based on live traffic, that traffic can be from trusted or untrusted clients. Trusted clients are those from whom you know the traffic is not malicious. Typical sources of trusted traffic are QA environments, internal test groups, or users in a controlled environment. There are several settings to configure when using live traffic to build a security policy. These settings are as follows: traffic source, continuous mode, track site changes, security template, and trusted IPs. The traffic source must be live traffic. Continuous mode gives you the option to run and build the policy at this point in time and stop or continuously run and discover entities based on a predetermined time. ASM will update the policy automatically if the policy builder is running in continuous mode. The default setting is to continuously run. So that's what is happening. It's continuously running in our lab scenario and keeps on updating us. So these are the settings, that those options it has. Traffic source, it will source of the traffic will default to live traffic. Continuous mode specifies that the security policy is based on new traffic log from the moment the policy builder is started until it stopped. Track site changes. When checked, enable the policy builder continuously detects differences between traffic and current active security policy and security templates. So that's basically how it operates on a regular basis. Now, how we can make use of the information it collects. So for that, we can refer to policy builder logs. The policy builder log displays changes and events that occur as a result of running the policy builder manually or from a wizard. This log displays security policy entities such as URL, file types, parameter, flow, header, negative signature, and blocking mask. The policy builder adds, removes, edits, also explains when and why the change occurred. You can also use the filter control to specify which policy builder action the screen displays. So if you want to look at the specific options in display, that also you can configure. The other option is track site changes. So track site changes allows you the ability to analyze traffic for entities that are different from those in the current active policy. Track site changes also solves the problem of site update and will update the policy automatically as long as the policy builder is running in continuous mode. Disabling track changes will generate learning suggestions whenever there is a discrepancy between the policy and the traffic. So if we look at this, the policy, and we look at the policy building and traffic, and go to the traffic learning option, whatever information pops up there is by virtue of this automatic policy builder. So yesterday we discussed about learning suggestions and how we can work on them, but these are generated by this policy builder, because policy builder on a continuous basis is getting the traffic, analyzing, and providing us this suggestions. Now in this case, if you look at this log, evasion technique is detected. That is the violation ASM has found. Now it's because IIS backslashes, that's the sub reason. Now if I have to look the details of this error, then what I can do is I can look at related suggestions, and I can basically expand this one. So it says action set enabled to on, match evasion technique is IS backslashes. Now 21 requests triggered this suggestion from so and so time date time till so and so date and time. So what this means, actually 21 suggestions have been there for this one. So it looks like a very common event. Now what action should I take is something which I can refer over here. So it accept suggestion. uh, Accept suggestion means set enable to on. That means this is a suggestion basically. So if I want to enable the IS backslashes in my policy, then I can just simply accept the suggestion, because ASM is suggesting me that, and these type of logs will stop coming in future. Then the other option is delete suggestion. So if I delete this suggestion, what will happen is that future similar logs can still come if this kind of violation is there. If I ignore suggestion, then what will happen is that this log will disappear, as well as future logs with similar kind of violation will not be reported by ASM in this left side section. So these are the three things that you can do. Now if you go 100% by the ASM without any knowledge of your own, then you can accept it, but I would say don't do it blindly. You should have some more idea about the application, what it requires, and or else try to fetch that information from the development and understand what this actually means, and then allow it. So as per my understanding of the error or the violation, this is something which is very much in common, so I would accept this suggestion. So once I accept, that is gone from here. Now I see another violation. The attack type is same, but the technique is little different this time. This time there is no IS backslashes, but it is Apache white space. So again, I have an option. If I accept this suggestion, what will happen? This will create one more pinhole in my policy. So I'm making policy a little more practical and relaxed than full tight one. So based on that, you can, if you want to select all of these, once you have viewed that and you think that all needs to be selected, it's easy to check mark to select all of these suggestions in one shot. And the thing that you should notice, there are different types of different categories of violation. It's not that all are similar. These are like, this one is HTTP protocol compliance fail, and basically bad multi-part form data request. Something was bad in the request, which was different than expected as per the HTTP RFC. So that's why it created that log. And request link exceeds defined limit. So that's another type of violation that it observed. So now I'm gonna accept it. And once I do that, all the logs will be disappeared from here. Okay, I just have to apply it. So I have made all these different types of exceptions to my policy, because I did not have the correct application information, so I could not do this at the first go when configuring the policy. So this is something policy builder has helped me. Track site changes, security templates. The policy builder will populate the security policy using one of the 3 predefined security templates. The security templates provide the configuration guidelines by which the policy builder creates or updates the security policy. The security templates levels are global URL flow. Now what are these? Global level security template allows you to protect and add file types and global parameters. You are also able to enforce request lengths, header lengths, cookie lengths, meta characters in headers, and attack signatures. If you run the policy builder using the policy wizard and you use the global level security template, ASM automatically adds HTTP and HTTPS wildcard URLs with tightening disabled. This is due to there is no positive security for URLs. It's only there for file types, just as an FYI, when using the global level template. URL level security template allows you to protect and add URLs. You have different URLs for an application. File types can be per URL base as well. and URL level parameters. You are also able to enforce request lengths, header lengths, cookie lengths, meta character in headers, and attack signatures. Flow level security templates combines the URL level template and also has the ability to protect and add flows and flow level parameters. Whichever template you choose will dictate that ASM will add to the security policy, meaning if you specify global level as the security template, the policy builder will only learn and add file types and global parameters to the security policy. Alright, domains. So I think we all understand what a domain is. So the policy builder uses domain settings to differentiate between URLs that belong to the web application and URLs that do not belong to the web application, right? So something like ABC ending with abc.com, all of the things ending with abc.com will belong to the same web application. Something ending with xyz.com definitely will be from a different application, that URL. So when domains are configured, the policy builder updates the security policy with entities from your web application and does not update the security policy with entities that belong to the external search engines. Okay, heuristics. The policy builder has a built-in algorithm that analyzes web application traffic according to the security template selected, right? So whatever traffic is coming in, the violation is basically the difference between the traffic coming in, the request coming in, and the policy configured, right? So from that analysis, the policy builder updates its corresponding security policy with web application entities, that is file types, URLs, parameters, parameter value types, and meta characters. So that means whatever we accept based on this learning suggestion, that is there updated. This analysis is called heuristics. As the policy builder runs, heuristics scan all of the web application traffic and detect additions and changes to the web application entities. When heuristics reaches a threshold in the algorithm, the policy builder makes corresponding changes in the security policy. Heuristics reduces the number of false positives received and reduces the workload of building a security policy. Note that heuristic is only performed on an untrusted traffic source. This is very useful in the case of parameters. When the policy builder is running heuristics on responses, it can determine the parameter type, like the parameter type is a username or what. For example, the web application may have a parameter that heuristics initially determines is a static parameter. If over time heuristic detect more than 20 different values for that parameter, then it doesn't remain static anymore, right? So then the policy builder changes the parameter type to user input. Alright, trusted IPs, very straightforward, something that we do a very common practice, and mostly for the whitelisting of the scanners IPs in our environment, or some kind of auditing machines IPs from where they might be trying to do the VPT kind of stuff. So when building a security policy, you have the option to use trusted traffic as its source. When using trusted IP, all the traffic that arises from the specific IP address is considered valid and will be added to the policy, right? So now this is the thing, that if you have configured an IP as a trusted IP, whatever traffic is coming from that IP, first of all, that traffic gets the privilege to be allowed, and is not considered any kind of violation. Second thing is what happens, as ASM knows that since this is a trusted IP, so it will if there is some request coming from that IP that goes against the default behavior or the configuration of the policy, then ASM will try, especially when the policy builder is on, then the ASM will try to modify the policy to suit that kind of request, because it understands that since it's a trusted IP, so the request that it's making is a genuine one, and since the policy is not configured right now to accommodate that, so it should be modified to accommodate so as to reduce the false positives. So it uses that logic and allows the different kind of genuine requests coming from different types of requests coming from the trusted IP at least. So you can configure that IP address as a range of addresses or a specific address. The trusted IP can come from a QA, quality analysis environment, or test lab network. Also, if the trusted traffic triggers any attack signatures, ASM will automatically disable those signatures within the security policy. So what will happen now? This kind of automatic fine tuning, you can say. So if that machine sends a request which triggers, let's say, parameter violation signature, then ASM will first of all allow the traffic, and secondly go ahead and disable that signature automatically, understanding that this signature is causing a false positive, right? So that's the advantage of creating trusted IPs. But make sure that whatever you do from the trusted IP is something which is very genuine and required for, because otherwise ASM may automatically modify itself and be open to some attack that you made from the trusted IP. For the outside machines, you can build a policy automatically based on trusted or not untrusted traffic, or based on self-generated traffic. The biggest difference between trusted and untrusted IP is sampling responses. When using trusted IP only, no violations are generated and no sampling of responses. It's very less logs and very less painful. When using untrusted IPs only, violations are generated and responses are sampled, like we have seen, because my IP was not trusted that in that configuration. Once you configure the trusted IP, you can view a summary page before finalizing the configuration. The summary page consists of security policy properties, attack signature configuration, the configuration mode, and the policy builder configuration. Finalize the configuration, generate traffic to the web application via the trusted IP, and the policy builder process will begin. You can view graphs on newly added file types, URL parameters, and flows during this period. This process, if running in continuous mode, the policy builder will continually run until it stops. So when we talk about the graphs, I would love to show you if we have got some graphs. Let me see, and it would come under the reporting section actually, which we tried to touch yesterday. We will deal in more detail in the upcoming sessions. So right now we don't have any reports configured, and hence we don't have any charts scheduled over here. Yeah, otherwise we can get some data logged in here and see the graphs. All right, no worries, we're gonna do it in the next session, so we'll hold on till then on this one. Okay, so the next one is wildcard entities. When building your security policy via any method, ASM automatically populates wildcard entities on file types, URL, and parameters. This we have noticed very often, that on all these three sections, primarily file types, URLs, and parameters, we have a wildcard over there. Wildcard entities implies positive security logic, meaning the wildcard any type of entity is allowed. For instance, if user adds the URL wildcard.php, any URL that matches the pattern wildcard.php match this URL and will be enforced according to this. So anything you put in front end that ends with a .php is going to be allowed by this wildcard. Regarding negative enforcement, if there is a match on a wildcard entity, ASM will not issue a violation, and the user can configure meta character, attack signature, negative checks. So you can also make a wildcard entity in the negative enforcement, right? For example, when we talk about the file types, we have when I go to file types, we have three categories for this: allowed file type, disallowed, and wildcard, and others. So if I have added, we have seen that we can add in the allowed file types a wildcard entity, right? And the same way in the disallowed file type also, which is negative enforcement basically, I can add a wildcard entity, that anything that's ending with that's PHP file type basically, I want to block it because I don't have PHP file type with me, right? So now this policy will not allow any request that has a PHP request or calling PHP file type, right? So All illegal meta character violation will be issued if a wildcard entity includes such characters. Signatures will also be triggered. The set of characters that can be used in a given entity is defined by the encoding language chosen for the web application, and in any case is made of a closed set of characters. The configuration marks some of them as allowed and some of them as disallowed. Options are meta character checks, attack signatures, or both. If there is a match on wildcard parameter entity, the user can configure meta character, attack signatures, or both for that entity. And wildcards can be configured for all these three, which we have already seen. Okay, when enforcing a security policy entity, the following order of enforcement is implemented. Search for exact. If exact is not there, then search for a match on pattern wildcard. If there are multiple pattern wildcard defined for an entity, the search order that is set in the configuration is the order enforced, right? So if you correlate this and visualize it in context to the file types, we can define a specific file type, and thereon we can, next line we can define a wildcard file type for PHP, something like that. So it will just check sequence by sequence, like it, normally a firewall policies or rules are checked. Ordering is very important because it allows you to increase granularity on definitions. Ordering can also be used in case an administrator wants to temporarily use a less granular definition such as wildcard while maintaining the other. Changing the order will cause requests to adhere to the first match while leaving the configuration unused but intact. The wildcard entity also allows ASM to create learning suggestions for requests that do not create any violation. It is good practice for most implementations to remove the wildcard entity from file types URL and parameter once the security policy building process is complete. That's what I was saying. So remember, we talked about it long back that in all these allowed file types and parameters and wherever by default there is wildcard, we should remove that, and that's what I've done already. So that shouldn't be there if you want to configure a new policy. Okay. So, policy building methodology is something that is very much we have covered, but I'll just quickly run through it, which marks the completion of module 8 as well. So there are several methods of building a security policy. You can create one automatically by using live traffic or self-generated. You can also create a policy manually. The following are the steps to build a generic security policy for a web application using live traffic and the manual process. So this talks about the manual option basically. Till now we were reading about the automated one. Create a pool, create an HTTP class profile. This we don't have to do now. This was something which was done in version 10. In version 11 onwards, we don't need a class profile. And now use an existing virtual server, run a deployment of the policy wizard, configure the web application encoding language and all those details that is there required for the policy. Place the security policy in transparent mode and log all requests. If the response scrubbing is not critical to your security policy, ensure data guard is disabled. This whichever is resource intensive, that's why. Configure the blocking mask so that the only important violations are marked as learn and alarm. For this implementation, only illegal object size, type, HTTP protocol compliance, request length exceeds defined, buffer size, illegal methods, length errors, evasion techniques detected, modified domain cookies, modified ASM cookie, and illegal dynamic parameter value are marked. Review the policy builder configuration and begin the building process. Generate traffic to the web application. This can be either production or QA traffic. Review violations, request and learn entities. Accept all false positives. Begin adding entities into the security policy. Perform steps 10 to 12 until there are no longer any violations and all traffic is illegal. So your policy is considered deemed to be perfect and ready to be in blocking mode once you see that ideally there is no violations coming up now anymore. Modify blocking mask to block gradually and continue traffic learning. So now the next topic Module 9 is security policy building tools. You like to go on now, or you would like to continue tomorrow?